attention. All right, your focus question for today is how can I use area and perimeter formulas when measurements or when side lengths are expressions. How can I use area and perimeter formulas when side lengths are expressions? So the first thing you need to get is the formulas. So we're going to talk about a rectangle first. And the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. 2 times the length plus 2 times the width. And the area of a rectangle is equal to the length times the width. In a square, the perimeter is equal to 4 times a side length. 4 times a side length. Because all the sides are the same, right? It's a square. Right, Halen? And the area of a square is equal to one of the sides, one side length, squared. Triangle. Alright, so for a triangle ABC, the perimeter is equal to A plus B plus C. This measurement that's going in here that's going to be attached to this dashed line, that's the height of the triangle. This symbol right here, this little half of a red box, that's the symbol for 90 degrees. The height of a triangle is always perpendicular to the base of the triangle, which means a segment representing the height intersects the base at 90 degrees all the time, always, forever. Area of a triangle is equal to 0.5 times the base times the height. And this is real important. Okay, the base and height are always perpendicular. And that means that perpendicular means they intersect at 90. Intersect and form a 90-degree angle. This is one of the symbols for perpendicular. Another one is this symbol right here, an upside down T. That's the symbol for perpendicular. All right, so now we're going to do, or I'm going to do a couple of examples for area and perimeter when side lengths are given as a expression. All right, so let's say you're given this rectangle and one side is x plus 5 and the other side is x. So look, the perimeter would be equal to 2 times a length. And you can use x plus 5 as your length, plus 2 times a width, and the width can be x. You guys remember distributive property from last year? A number outside of the parentheses and a variable and a number inside the parentheses means that the 2 has to get multiplied by the x and by the positive 5. So this becomes 2x plus 10 plus 2 times x, which is 2x. So now you can combine like terms, and 2x plus 2x is 4x plus 10. There's your perimeter. The area is equal to length times width, right? So the area is going to be equal to the length, which is x plus 5, times the width, which is x. And this is another example of distributive property, but the single term is on the right-hand side. So the area of this shape would be equal to, you can take x and multiply it by x, and you get x squared, plus take 5 and multiply it by x, and you get 5x. So the area of that rectangle would be x squared plus 5x. Any questions? It's like it's just review, isn't it? Let's try a square. Let's try a square with side y minus 4. The perimeter would be equal to 4 times a side length, and in this case one side is y minus 4. So again, for the perimeter, that's going to be the distributive property. So 4 times y is 4y. And 4 times negative 4 is negative 16. So your perimeter would be equal to 4y minus 16. Now the area is going to be equal to one of the sides squared. One of the sides is y minus 4. So y minus 4 squared. That means to multiply it by itself. So that is y minus 4 times y minus 4. And this is the distributive property twice. You have to distribute the y, and then you have to distribute the negative 4. So your y times y is y squared, and your y times negative 4 is negative 4y. Negative 4 times y is negative 4y. And negative 4 times negative 4 is positive 16. The two 4y's will simplify. So if you combine like terms, you got y squared minus 8y plus 16. There's your area. Questions? All right, let's do an example of a triangle problem. Look at, on page 38, look at number 5. On page 38, problem number 5. Does everybody see the M after every dimension? That's not a variable, that just stands for meters. Okay? The only variable in that is along the bottom, the x. Alright, so I'm going to do a problem that looks like that one. Alright, let's say you got a 6, 14. Down here at the base you got a 3 and you got an x. The height is equal to 4. Now this 3 along the base represents this much of the base. And this x represents this much of the base. So if one piece of the base is 3 and the other piece is x, what would be the entire base? 3 times x or 3 plus x? 3 plus x. Very good. So your base is 3 plus x. Alright, so your perimeter would be equal to the 6 plus the 14 plus the 3 plus x, which is the sum of the sides, the 3 sides. Alright, so 6 plus 14 is 20, plus 3 is 23, plus x would be the perimeter. The area is equal to 0.5 times the base, which is 3 plus x, times the height, which is 4. Now, you've got 0.5 times 3 plus x times 4. The easiest thing to do here is to multiply the 0.5 times the 4 first, because order doesn't matter in multiplication. And what's 0.5 times 4? Good, that's 2. So you got 2 times 3 plus x. So now if you distribute the 2, you're done. Alright? 2 times 3 is 6, plus 2 times x is 2x. So your area is equal to 6 plus 2x. Distribute this 2. So it's 2 times 3, which is your 6, and it's 2 times x, which is your 2x. Alright, so I've done an example of every one of the problems that you're going to have on your assignment today. Clear? Alright, your practice for today, or your assignment for today, is on page 38. Problems 3 through 5. And then 10 through 12. It's also your responsibility to check headline for homework. And it's also your responsibility to track Irma. Track the storm.